So this is going to be our architecture for the bus tracking system. So we are going to see two different types of use cases here. One is to uh, do the device monitoring, and another one is we are going to build an API to get the live location of the bus. Here we are going to have a combination of both event-driven architecture and a serverless architecture. And for the serverless architecture, we are going to make use of the AWS microservices like Lambda, DynamoDB to achieve our goal. To start off, when the bus moves, or the GPS location is going to be shared by the GPS device, and it is going to come to the AWS IoT, and once it reaches the AWS IoT, it is going to trigger an IoT rule, and once the rule is getting triggered, we are going to have a Lambda which will get triggered by the IoT rule, and the Lambda will query the DynamoDB to get the required details and also to put the items they required in the DynamoDB table. And finally, once we do the processing, we are going to publish our result to the SNS topic. So you create the role, and you can give here you can select the AWS service as Lambda, and next, and then what permission you wanted to give for these Lambda. So here in our case, the Lambda is supposed to interact with two things. One is it should query the DynamoDB table, and it should also have the authorization to publish over a particular SNS topic. So we need to choose the right executions role. In my case, I have already created the role, and I have chosen the DynamoDB access as well as the SNS access roles. Permissions, and I have attached to the roles, and I have created the roles. So create the role, and next one is to create the Lambda function. So in order to create the Lambda function, you have to fill in all this information. You have to give a suitable name and choose Python environment as your runtime, and in these change default execution role, you choose a use an existing role, and whatever role that we have created in the step one, we need to attach that role. So in my case, the role that I've created is Lambda to yeah, this one, IoT Lambda DynamoDB, because my input is going to be IoT and my output is going to be DynamoDB. This is what I have created, and I have attached the policies related to DynamoDB and SNS to this role. So I'm going to select, I have already created, and for my function I have created these role, and I have attached. Okay, so once you create it, and yeah, I have already created the function, you can go ahead and create it. So once you create the Lambda function, the next thing you need to do is go to the code part of it, and copy come back to the GitHub, copy the lambda function.py code snippet from here, and paste it here. So yeah, paste it here, and once you paste it, you can also configure the test case for this by create a new test event, give a suitable name, and you can give these particular latitude and longitude as your test case, and you can save it later purpose. But we need to come back here once again to update the topic here and later. Okay, so yeah, we will come back to that later. Now continuing with our flow, so now we have created the AWS Lambda, and we have attached the right role to it, and we have copy pasted the Python code also. Now the next third step is to create the IoT thing. Now in order to do that, so in for my demo purpose, I have made use of my Mac itself to do the device publish of the GPS coordinates. So if you're trying to make use of your own device like a Raspberry Pi, or if you have a Windows environment, you can choose accordingly. So let's go to AWS IoT core, and you click on connect one device. So you can try these things, and then you can make sure that your device is compatible for this IoT thing. And the next thing is to use and click on next. And here you need to, this is what is important, here you need to choose the right environment. It could be a Linux, a system like a Raspberry Pi, or a Linux OS, or you can give a Mac OS, and you can choose the windows also. So once you select that, the next thing is you will be given a download kit, kit to be downloaded. So you can download this kit, and once it is downloaded, next you need to once unzip that downloaded file and then click on the next. So what you will have is that once you have that downloaded file, you need to extract that file with the extract command, and after that you need to give these execute permission for the start.sh. So once the start.sh is given that executable permission, you need to run the start.sh file. Okay, so once it has run, just what it will do is that it will try to uh, uh, install the suitable SDKs, and also it will try to subscribe, it will try to contact the MQTT broker here at AWS IoT Core, and it will try to publish the data. So once it is done, you will start seeing the messages here. Okay, you will start seeing the messages here. You can pause, and then you can stop your script, and then you can come back to the GitHub, and where you need to update certain files. So you need to go to this particular path. You will, once that script is stopped, it would have created this folder called as AWS IoT device SDK Python v2 slash sample slash pubsub.py. So you need to open that file, so that pubsub file, and come down to the line number 133. So you need to replace whatever is there between 133 to 145 150 with the code snippet that pubsub.py. So once this, you come to the start.sh and you execute the start.sh, and you can start seeing the latitude and longitude being published on this particular topic. Previously some other data would have been coming. Now this latitude and longitude message will start coming. So if that is done, then our step 3 is completed. Now coming to the step 4 is to create the IoT rule. So in order to create the IoT rule, come back here and go to the message routing in the IoT core, and go to rules and create the rule. So I have already created the rule, so you can go ahead, create the give a name, okay, and give a suitable description, and then you can create, and then here you update the SQL statement as mentioned. As here you can give select star from, this is the topic that we in which we are going to publish the device data, so you can paste the SQL statement here. So there is one single quotation at the end, so don't forget to include that. So once that is done, next is to choose the action. So here what you need to do is that we wanted to trigger a Lambda. So you just select the Lambda, and the Lambda that we have created on the step 1, which is the bus tracker, you try to give that bus tracker, and then click on the next. So once that is done, we can go ahead and create the rule. I have already created the rule, so for now I'm going to discard this. And once the rule is created, the next step is to create the SNS topic. So in order to create the SNS topic, let's go to AWS, and you can create a topic here. Select the standard and give a topic name and this suitable description, and then you can go ahead and create the topic. So once the topic is created, you will get it displayed here. You can go ahead and then create a subscription there. So I'm going to create a subscription here. I'm going to give the protocol as email, and I'm going to give as a subscription. So if you see, after you have created a subscription, you will start getting spam. So you just check your spam folder, and you message it as not a spam, and it will start coming into your inbox, and you need to go and confirm this subscription. Then only you will be able to get the SNS notification. So then now we have subscribed. Now if we come back to our AWS SNS console, we can see, and if you just refresh, you could see the subscription is confirmed. So now this is also done. Now the last step is to create the DynamoDB table. Now let's go ahead and create the DynamoDB table. Go to DynamoDB, create a table. So create a name for the table, and In the partition key, you have to mention the bus ID as the partition key, and the sort key you mention the timestamp as the sort key, and both it be strings. And let let other default settings be there, and you go ahead and create the table. So I have already created the table. So my table name is bus underscore live underscore location, and my partition key is bus ID, and my sort key is timestamp. So let's go ahead and see the content. Yeah, we have some from 50 content. So for this demo, let me clear these items. Okay, so now we have cleared the items here, so we don't have any entries here. Now we have done all the steps. We have created if you come back to this presentation, you have created the IoT device, we have created the IoT thing, and we created the IoT role, and we created a Lambda, and Lambda has the IAM role to query the DynamoDB and as well as to publish the data to SNS. We have created the SNS topic along with subscription, and we have created a DynamoDB table, and all this information we need to make sure that everything is correct in our Lambda function. Let's come back to Lambda function, and let's check the naming for all these things. Is bus live location, the table name, and we have to make sure for the topic also if we have used the proper topic or not. So that is also done. So now with all these things done, let's go ahead with the demo. So this is my file. I'm not going to, this is my device. I'm going to publish the latitude and longitude from here. So from my device, I'm publishing the latitude and longitude as 0.1 and 2.1. And let me go to the, and let's go to the DynamoDB table and see if we are getting the data there or not, because previously we have cleared the data there. And if you see, explore the table items, yes, we have started getting the data. And if we see our email, yeah, we have started getting the bus locations on a live locations. We are getting the bus is approaching. Yes, the bus has reached your destination point. And so now what's the location? It's 14.1 and 16.1, and in the Lambda function we have given our current location as 10.1 and 12.1, I guess. Yeah, I don't know what's the latest message. So the latest message is the bus has left your destination point. So we will keep on getting these messages. We can go ahead and unsubscribe to this topic so that the user will no longer get these messages. So I'm going to go ahead and remove the subscription so that I will not get any other further messages. Okay, so this is the bus tracking. Yeah, we have unsubscribed. So this was the demo where I wanted to show when we run a GPS device, and then when we push the data to the IoT, we were able to put the data to the DynamoDB table, make some processing, and with that processing we were able to find out the proximity of the device, and we were able to publish the data to the SNS. So the thing is to create the API for the live location. So for that, let's go to AWS API gateway. And you can go ahead, create an API, and here you choose the REST API and give a suitable API name, give a regional name, and go ahead and click on the create. So once you create the API, you start creating the resources, and once we create the resources, let's create a method, and in the method you make sure you call the you choose the integration type of AWS service, and in the region you give the region in which you have created the DynamoDB table, and the service is going to be DynamoDB. And once you give that, the next thing is to give the suitable action name. So in our case, the action is going to be the query action. Okay, and then we have to give the request body, and here we will be mentioning what type of which table we wanted to query. So I have already created the API. You can go ahead and see this. Yeah, you can see, yeah, I have created a resource called as bus location, and then created one more resource where I can pass the bus ID, and here I have created a method, and in that integration request you can see in the integration request, you can see I've given action name as query, and choose the request body pass through, and then choose the mapping templates. Here you give the application bar JSON, and in the template body you try to mention the table name, what is the primary key, what is the sort key, and what expression you wanted to query. So in my case, I wanted to query the bus ID, and then I wanted to get the top bus ID, which is sorted in the descending order based upon the timestamp. So it will give me the latest bus. So now let's go ahead and make use of this query, and let's try to use it in our okay. Okay, I'm passing the bus number 100 here. Yeah, we got the bus detail. So where it is currently, it is showing. See, if you see the bus is being sending the GPS coordinates. It is saying it is in latitude 60.1 and longitude 62.1, and we are getting that exact. Yeah, when we queried, it was the latitude was 58.1 and the longitude was 60.1. Yeah, so right now it is 64.1, 66. Now let's refresh this, and whatever is the top, yeah, we got the latest location here, and what is the timestamp that we got here. So if we try to integrate this with an application, the application can make use of this API, pass the bus ID here, and it can get the live location of the bus, and they can show it in their beautiful HTML page. Yeah. So with this, the demo is completed. Thank you for watching, guys.